All right, so this is the 3.6, I'm pretty sure, homework. So we're going to look at a few of these and hopefully try to clear up any questions you may have before I get back. So first of all, we're looking at complex numbers. So that's kind of an extension of imaginary numbers. So first of all, if you're just adding and subtracting two separate parentheses, I mean, really, you just have to add and subtract the like terms. So this is just combining like terms. Like I'll show you on number 2. You can do this one of two ways. You can start over here and say -6 minus 1. That would give me -7. All right. Then you could say 10i minus -2i minus a negative becomes plus. So that would be plus 12i. Another way you could do this, because I know that some of us struggle with our signs, act like this is a plus sign and then make your negative be something that you can distribute. And you could say this is plus -1, so that would just be -1 plus 2i. Then you could just say, okay, -6, -1, -7. Then you could say positive 10i plus 2i is 12i. All right, so that's the first part. All right, so let's keep going. Let's go to number 6. So you'll see on number 6, before then you have some distribution. You just distribute here, same kind of thing here, except this is minus. Here you would just FOIL. Here you would just FOIL. So let's do this one just because. All right, so number 6. So there's no plus or minus in the middle of these parentheses, which means they are multiplied, which means we have to FOIL. Now, there's no trick for this one. We just have to FOIL it. So FOIL means first, outer, inner, last. Essentially, here's what we're going to do. We are going to distribute the 3, the -3, we're going to distribute it to two places, the 1 and the -2. Then we're going to distribute the -8i to both places as well. So that's how it ends up looking. Some of us have struggled with this, so that's how it looks. Now, when we take -3 times 1, that's -3. -3 times -2i would be -6, and actually it would be plus 6i. All right, now when we do -8 times 1 minus 8i, and then when we do -8 times -2i, we get plus 16i. And actually that would be plus 16i squared, because this I times this I gives us I squared. All right, now that's typically going to happen with a lot of these, I'll be honest with you. When we multiply, a lot of times you get this that pops up, which we just have to remember I squared equals -1. We'll be good to go on that. All right, so now let's combine like terms. So let's see, -3, we don't have a like term with that for now, but we do have like terms right here and right here. So -3 plus, actually that would be minus 2i. Now, this plus 16, we can change this to, we can change this I squared to -1. So now I'm left with -3 minus 2i minus 16. And now I do have a like term here and here for -3 and 16. So that would give me -19 minus 2i. All right. So, hang on just a second. Let me move something over. All right. So now let's go to number 7. Because number 7, there's actually a little bit of a trick here. I've already told you this before, but when you have any set of parentheses and there's a plus or a minus, you can't just say -7 squared plus I squared. You're leaving out a major missing part. So what you have to do is actually use this as -7 plus I times -7 plus I. You have to actually repeat the parentheses and multiply them, which means we FOIL it, or there's a trick we can use. It's really up to you if you want to use it or not. I'll show you both ways. So here's what it looks like just foiling. We would say -7 times -7 is 49. -7 times a positive I is -7I. Then we would take I times -7, so -7I, and then I times I, which is plus I squared. All right? So then we combine like terms. We would get -14I here and here, and then we can change this to -1. All right? So what we actually have is 49 minus 1, which is 48, minus 14I. Let me double check. Yes, that is the answer. All right. Now, I've told you this a couple times, but I'm going to show you again. There's another way we could actually FOIL this. Now, the reason we can use this trick is because this parentheses is squared. So when it doubles up, what we can do is take the first term, square it. So -7 squared is 49. We leave a space and we take the second term, square it. So I squared. And then in the middle, we take 2 times -7 times I. So we basically take each of these terms, we take -7, we take I, and we multiply it by 2, so that gives us -14I, and you'll notice that's what we got before. Now we would just do the same exact approach, make this -1, so 48 minus 14I. All right, now let's go to the last part. So number 10. Number 10 through, let's see, number 10 through 16. You'll notice that there's an I on the bottom, and we can't have I on the bottom because technically I is the square root of -1, and you cannot have square roots on the bottom of fractions. It is a massive, it's a massive no-no. So what we can do is we can either multiply by I to get rid of it, or you'll see we'll do another thing in a second called multiply by the complex conjugate. So it all depends on if there's just a single I on the bottom or if there is a plus or minus. So if we go back to number 10, which let me see, maybe there's an easier one, or not an easier one, but a harder one. Let's see. No, I don't see one. All right. So let's just stick with, actually, yeah, let's do a harder one. Let's do 12. So on number 12, we have I on the bottom. We can't have I on the bottom. So as long as there's no plus or minus on the bottom, you can just multiply the top and bottom by I. Now, what's that, or what that will give us is I times 8 plus 4I, and we're actually going to have to distribute there. Then we will get 2I squared. Now, you'll see on the bottom, we've introduced I squared. That's why the I on the bottom is going to go away. All right, but first we have to distribute here and here. So 8I plus, let's see, that would be 4I squared over 2. Now, this becomes -1. All right, so then 8I plus 4. Now, this also becomes negative 1 over negative 2. All right, so then we actually have negative 4. We actually have negative 4 plus 8I over negative 2. Now, this is where it gets a little, I don't know, it gets a little weird doing this final step. This is actually something that you can't really divide unless you split it up. So when this plus sign is here, it actually means we have two separate fractions shoved together. Here's how it looks. It looks like negative 4 over 2 over negative 2 plus 8I over negative 2. So if we want to reduce this, we have to split it up this way. So that would give me 2 minus 4I. And you will have to reduce these. So pay attention to if you can reduce this. The best way to do it is split it up. When you split it up, if both of these fractions will divide, then you can go ahead and divide those. But I'll show you an instance where it won't divide, which a lot of them should divide. But like, let's say for some reason, instead of a 4 here, a negative 4 here, I'm going to change it real quick. And let's say we had negative 5 there. Negative 5 plus 8I over negative 2. What would happen is we would essentially have to not be able to reduce this, but we could switch the signs around. We could say, okay, I know this is the same thing as negative 5 over negative 2 plus 8I over negative 2. So all I could really do was change the signs. Like I could say, okay, this changes to 5 over 2 plus that would actually divide. But you could write it one of two ways. You could write 5 over 2 minus 4I. You could write it like that. Or you'll also see it left this way. You'll see it left as 5 minus 8I over 2. That way you can write it all together. But I don't know. That's kind of some extra stuff. That'll be something I have to show you because that's a very difficult thing to do. But hopefully in this video it kind of makes sense. But we'll see. All right. So then the last one I want to look at, maybe not the last one, maybe two more. But I want to look at number 14. So now number 14, the difference between 14 and 12 is that 12 on the bottom was an I, but it was just 2 times I. On the bottom of 14, it's 1 minus I, which totally changes everything. We can't just take I now and multiply it on the top and bottom. That's not going to work anymore. What we have to multiply by is the complex conjugate. The complex conjugate basically means this. Multiply by whatever this is, but change the sign. So whatever sign's in the middle, just change it. So now we would multiply by 1 plus I and 1 plus I. All right? So then we get 6I times 1 plus I over, now you'll notice here, we actually have to FOIL the bottom. So the bottom is 2 separate parentheses multiplied, and we have to FOIL that. So 6I, when we distribute here, 6I plus 6I squared over, when we multiply here, we would end up with, 1 minus I plus I minus I squared. So then we end up with 1 minus I squared because these two would cancel out. All right. Now we can replace all the I squared parts with negative 1. So 6I plus 6 negative 1 over 1 minus a negative 1. So that becomes 6I minus 6 over, this would change to plus, so that would be 2. Now, here's another situation. This is technically two separate fractions broken up. This actually would look like this. It would actually look like 6i over 2 minus 6 over 2. So we can divide both of those and get 3i minus 3. Or you'll actually learn that you can do it this way as well. But I think for beginners, this is the best way to do it. And then if you break it apart and they won't divide, just keep it all together like this. But we broke it apart and it would divide. So this is our final answer. All right, let's do one more. So 16 could throw you off because of this negative, but here's what you have to notice. There's an I on the bottom. We don't want an I on the bottom. There's a minus sign. We can't just say times I when there's a minus sign. We have to actually use the complex conjugate. That means don't pay attention to this sign. Pay attention to the sign that's in the middle. So the complex conjugate here would be negative 1 plus 4i on the top and on the bottom, which means we would end up with this. We would end up with 5 minus 8i times negative 1 plus 4i over negative 1 minus 4i negative 1 plus 4i. So if you notice, we actually have to FOIL on the top and the bottom, which sucks, but we just have to do it. All right, so let's see. The top is going to give us, let's see, 5. Let's see, negative 5, and then it would give us 5 times 4i would be plus 20i. Negative 8 times negative 1 is plus 8i. Let's see, negative 8 times negative 4 would be minus 32i squared all over. Let's see, negative 1 times negative 1 is 1. Let's see, negative 1 times 4i is minus 4i. Negative 4i times negative 1 is plus 4i. And then negative 4 times 4i. So that would be plus 16i squared. All right, so now we can combine like terms, which are always going to be in the middle. Right here, right here. All right. So negative 5, let's see, 20 and 8i would give us plus 28i minus 32. We can also go ahead and replace this negative 1. We could put that where I squared is. Then we have over 1. This would just cancel out and give us 0. So we can say plus 16. Now this I squared also becomes negative 1. All right. Now we've got this becomes plus and this becomes just minus 16. All right. So then we've got negative 5 plus 32. So it's going to give me 27. We have plus 28i over. Then this would give us, what, 17? No. What am I doing wrong? Oh, this should have been minus 16. Hang on. Let's backtrack a minute. I made a mistake. My bad. When I did this portion right here, I jacked it up. This positive, or this negative times this positive would make this portion negative. So I'm glad I caught that because I would have looked like a fool. All right. So this is actually, let's do this. This is actually minus. All right. So that means this would become plus 16. Boom and boom. So this is plus 16, so this would be 17. Now, notice this. It doesn't matter if I'm looking at this number or this number. Both of those won't divide by 17. So I don't even need to split this up. Because if I split this up, here's how it would look. 27 over 17 plus 28i over 17. And there's just nothing that I can do with that. So I don't go any further. I just leave it like this. All right, I do want to say this as well. Don't worry about don't worry about saying if it's complex or whatever, like name all the sets. Don't worry about that part. We're not doing that. It doesn't really matter. All right. So I think that's it for this video.